Hi friends, my name is Rohan. In today's video, we are going to discuss the crude distillation. So, in refineries, the the separation of the crude oil is take place of into the various fractions by distillation in a atmospheric or atmospheric tower or a vacuum tower, right? So. So further the main fractions are are obtained by the specific are having the specific boiling point ranges, and by reducing the volatility of that crude oil into the gases, uh, medium distillates and high distillates, like and gas oils and residuums. So in the atmospheric distillation, desalted feedstock is preheated using the recovery process heat, so that the it is further flows into the main distillation column. uh, as you can see here, the it is preheated using recovered process. The desalted is preheated using recovering process. The feedstock is further flown into the direct heat, crude oil charge heater, that we can call as the uh, furnace heater, into a vertical distillation, then into the vertical distillation column just above the bottom. And further, the pressure is given just above the atmospheric pressure, and the temperature is around 340 to 370 degrees Celsius, so that uh, the undesirable cracking could not take place. So as the hot vapor rises in the temperature, as the hot vapor rises in the distillation column, vertical distillation column or tower, the temperature is reduced. So high and the fuel oil is removed from the bottom of that distillation column, such as the fuel oil, asphalt residue is taken from the bottom. And at a higher point of that distillation column, higher point of that tower, the various products, including the lubricating oil, gasoline, kerosene, etc., and uncondensed gases which condense at low temperature are drawn off. As you can see here, the desalted crude oil is fed to the furnace, so that it can be taken place heat could be taken place, and that in such a way that their flash point should be a uh, in suitable manner. And it is further fed to the distillation column just above the bottom, and it is acted in such a way that the from the vapors are going up, light particles will go upside and heavy residue will settle down, and better contact take place in this atmospheric fractionation. So there are many products we get from this distillation. So right now, vacuum distillation, the residue from taken from the atmospheric distillation, or uh, residue taken from the atmospheric distillation tower, or it can be further distilled in such a way that thermal cracking should not be take place, and temperature, so that the pressure should be reduced, reducing should be required, right? As you can see, the distillation residue from the atmospheric tower without thermal cracking, reduced pressure is required, right? The Now these can be taken place, these vacuum distillation products can be having more than one or multiple vacuum distillation, in such a way that the market demand, or uh, certain products should be given from the vacuum distillation, should match the uh, what we call certain parameters, right, or certain demands of the public. So these can be taken multiple vacuum distillations also in stepwise. And in internals of the vacuum distillation is internals of the vacuum distillations is slightly different from the atmospheric distillation tower, in such a way that instead of using tray, we will use the uh, demister pads, or packing material, in such a way that the contact between the liquid and vapor should be high, and surface area is high in the packing in when we use the packings instead of the tray, and pressure is reduced in such a way that the energy is efficient to use in vacuum distillation. And uh, uh, further further the first phase of vacuum is product distills the heavy residue from the bottom, should be taken out such a way that the lubricating stocks lubricating base stocks, and other material are are taken from the bottoms of the vacuum distillation tower, and fed to for the propane deasphalting. So next is second vacuum distillation is taken from the residue from the first vacuum distillation, in such a way that these residue of the product of this second vacuum distillation tower uh, is not fed to the uh, propane deasphalting, right? So it is further it is taken from the atmospheric distillation as an input residue, and further it distills, and these vacuum distillations are used for the catalytic catalytic cracking, right? Separate the user to separate catalytic cracking feedstock from the surplus residuum. So this is the vacuum distillation. So residue from the atmospheric distillation is fed to the furnace so that it can be preheated, and further it is fed to the vacuum distillation. We get the vacuum residue from the bottoms, and top of the tower we get the vacuum gases, vacuum gas oil, lubricating oil, right? Now you can see these modern crude distillation surfaces. First the furnace, we go with the furnace to heat that crude oil and main dish fractionator, it goes with the main fractionator. Now here what happens is that the stripper is used for many of the components like kerosene and intermediate gas oils contains the contaminants, right? Many of the gas oil contains the contaminants, right. It is fed to this stripper in such a way that steam is fed in that, and and some of the gasoline contains the light residue, like it can be more, it can be, it has a less flash point, so that it can be feedback to the main fractionator, and it is further it further take further do the contact between in the it in the main fractionator vacuum distillation, in such a way that it can vaporizes as the taken product as the gases. So final products we get is these all things. So you can see here we uses two vacuums. One is here vacuum residue, and here also vacuum we have. There are multiple vacuums we can use. So thank you.